السلام عليكم ورحمة الله وبركاته. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. اقرأ باسم ربك الذي خلق. خلق الإنسان من علق. اقرأ وربك الأكرم الذي علم بالقلم. علم الإنسان ما لم يعلم. كلا إن الإنسان ليطغى أن رآه استغنى. إن إلى ربك الرجعى. أرأيت الذي ينهى عبدا إذا صلى. جزاكم الله خير. السلام عليكم ورحمة الله وبركاته.
Thank you, Mr. Ubaydur Rahman. Now I call upon Mr. Zayed Zubair, first year MCA, to present the welcome address.
Good evening, honorable person here. I am Syed Bell. Welcome each and everyone to a webinar on machine learning using a Python. We are honored to Dr. A. Kalaivani, Professor and Department Information Technology from Rajalakshmi Engineering College, Sunderland. Joining us today, delivered today webinar, our expertise in machine learning will guide us through this section. A warm welcome to exhibited resources person, convener, director, assistant director, head of a department, faculty members, students, and participants. Your presence adds immense value our discussions today. Once again, warm welcome to all.
Thank you, Mr. Zayed Zubair. Now I request Dr. G. Lalita, Assistant Professor, to introduce about our resource person. Lalita ma'am.
Lalita ma'am.
Dr. A. Kalaivani, currently working as a professor in the Department of Information Technology and associated with Rajalakshmi Engineering College. She has 22 plus years of teaching experience and her main research area are data mining and computer vision. Her research contributions have culminated in 34 reputed publications, which includes 5 journal papers indexed in Web of Science, 9 presently in Scopus indexing, and 20 in Google Scholar. 4 papers published and 13 papers presented in international conference, and 5 papers published and 13 papers presented in national conference. She published 13 book chapters in reputed international research books. She is an editor of Scopus Index research book, AI Innovations in Medical Imaging, published by IGA Global Publishers in 2021. She is also an author of the book Data Structures. She has published the Indian patent, Australian patent, and design patent. Profile indexed in World Book of Researchers from 2019 onwards. She acted as a resource person and delivered research series of talk in premier institution within Tamil Nadu. She acted as a chief guest for technical and non-technical programs and also acted as a section chair. She is a former trustee for PT Lee Chengalvaraya Nayakar Trust. She is an approved DC member for Wales University and SRM University. She is a recognized supervisor of Savita University and currently produces 2 PhD candidates in the domain of aspect-based sentiment analysis and multi-label image annotation. She received a Best Teacher Award from Lions Club International, South Indian Best Non-Circuit Faculty Award from ASDF Organization, and Women Researcher Award from VGood Technology. She is a reviewer for various reputed international journals and also served in the program committees of several premier institutions and international conferences. She is a life member of IAM, IFERP, ICSES, CSTA, ASDF, and an institutional member of IET. I welcome Dr. Kalaivani ma'am once again for our webinar session. I hand over the session to Kalaivani ma'am to make her presentation now.
Thank you, Dr. Sabri sir. Shall I start my session?
Yes, ma'am.
Okay. Can you want the screen to be made full screen or shall I continue the same form?
You can make it as a full screen, ma'am.
Okay.
Yes, ma'am.
Go for the slideshow, please.
Good evening to everyone all present here. Great opportunity has been given to me to engage you with the upcoming topic on machine learning and also how this machine learning can be used with Python programming. The agenda of today's session's plan for me is, let me give an insight on machine learning, where and all this machine learning has been applied, what are the different types of machine learning, most important algorithms used in the field of machine learning, what are the challenges that has been left in the machine learning, which can be taken as a keynote for researchers or students to take up their projects, and how will you teach a machine to learn. A small demo, small example over there is there. Let me explain you that. And then for having or doing a machine learning research or project, what are the requirements are needed, and 2 or 3 examples with the Python code. So this is a plan for today's evening session. So what is machine learning? It is a subset of artificial intelligence. Actually, what is artificial intelligence? We have human intelligence. We use this human intelligence to take up the decisions. Now, we want a machine to do the same process. For what purpose? In order to work faster than us and it should not get tired. So focusing on this machine intelligence, they have come up with the various algorithms and also they have come up with the statistical models. So these algorithms will make the machines to think, to learn, and also to make predictions as similar to our human beings. But do we need to write a program for this? Program, it's not the case here. In further slides, I'll tell you how traditional programming and the machine learning model differs. What is the base mathematical foundation required for this machine learning is, you need to know a little bit about statistical techniques and also linear algebra and how to train the model. And once we train the model also, we need to check whether the performance is able to achieve as expected. Okay. So this is the next slide where we are going to talk about all, I think students are here, scholars are here, faculties are here. We have been working on programming, right? Now, how can I make a difference with this programming along with the machine learning approach? So in program means everyone knows that we'll write a program, we'll execute the program. On execution of the program, we'll supply the data, it will do some processing and get us the results. Okay, this is our traditional programming things. So we have learned a lot of programming languages, C, Python, Java, etc., etc. Okay, now how a machine learning approach comes over here. So here also we need with the data. So here we are not going to do a programming, we are going to build a model and we'll also give the results. Okay, and what will be the output coming out of it is the model is built. So that's what that model, instead of using the word model, there I've given a program. So here in your traditional programming, you're giving data, program, that is your input data, program. This input data works in the program and get the results. But in your machine learning approach, you're giving data, results, and you're generating the model. So what is actually this results? What is this data? Let me tell you an example. You take a medical diagnosis. Okay, for example, let us take a medical diagnosis of a women breast cancer, which is a top second largest problem to be addressed in India, right? So in this women breast cancer diagnosis, I have a data sets, right, that have the features of all this women cancer symptoms for a patient. And also, so that is your data right now. Then what is the result here? Along with all the features, which means I'm taking the previous patient's records. Along with all the features, I'll also have a class label called results that will have whether the patient is having a cancer or not. So this is the results what you have. Actually, in machine learning terminology, you have to call this as a class label. Now, I'll give the previous history of records and the class labels. Okay, and with this, the model will be built. So this is your machine learning approach. Is it clear? Right. And this is a flow chart that shows the difference between your traditional programming as well as your machine learning approach. So as we told you, I have a program at my hand. I can write the rules and I can evaluate the rules. If the rules is correctly passed, I'll get the results. If the rules are coming out wrong, giving wrong results, again we'll fine tune the rules. Okay, this is how we do our programs. We expect something, we'll write a program, we'll give the input, we'll check whether the input gives the desired output. If I'm not getting the desired output, there is no logical error, no syntax error. So what we'll think? There may be some objective or code part, what we have written is not correct. So our logical part, again, you'll check it out. You'll refine that program and again you'll get the better results. This is a normal traditional programming approach. Now, when coming to machine learning approach, what I'll do here is, as I told you, I'll have my data, I'll have my results, right? So now you will build the model. The model is built. That is what we have talked in the previous slide as program. The model is built now. So the model is built right now. So what happens here is this model has to be validated or evaluated. Why? How come you know that whatever the model that is built is giving a accurate results? So again, part is called as your evaluations. This evaluations is able to give me the expected results, or the model is coming up with a better accuracy, means I can stop with this. Suppose the model is not giving a proper accuracy, means again have to fine tune the model. So earlier case, you have fine tuned the program. In machine learning approach, we are going to fine tune the model. So this is a technical definitions given by the computer scientists or machine learning engineers. What is machine learning is, it's nothing but learning is any process by which the system improves the performance from experience. Performance means what here? It is a model performance. Experience means what? How the model is built. The model is built based on the data you're giving it. That data is only called as your experience. Suppose in our day-to-day life, we are facing some problem. How will you get the solutions? We'll think of similar problems, what we have handled, or we'll get the solutions from the expert opinion. Like that, we'll do it. That is what is called as an experience, what you apply in your day-to-day life. The same manner for a machine learning projects or your work, whatever you do it will build a model. The model is built based on the data what you give only. You cannot say that the model what I built is correct, the model what you build is wrong. The model is built only based on the data what you give. So depending upon the data only, the model will be evaluated. Okay, and apart from that, Tom Mitchell, important persons, we have given the definitions for the machine learning in the following manner. It is a study of algorithms that has to focus on improving the performance. 3 parameters are given here: performance, task, and experience. P is the performance, T is the task, and E is the experience. Okay, so in this women breast cancer diagnosis, okay, what is the performance we expect? The performance what we expect is should be similar to the experience or the performance what we expect from the radiologist. The radiologist will accurately diagnose the patients whether having a breast cancer or not. The same performance we are able to achieve with the machine, means we can reduce the work of the radiologist, and also we need not depend on the persons, or we need not depend on the medical experts, right? So we are getting the information of diagnosis, but we are not going for the treatment. Obviously, any computer diagnosis cannot replace the doctors. Okay, we are able to reduce the computation parts. Only we are able to support them on the computation area, not on medical treatments. And what is at some task? What is a task over here for this example? In this example, we have to identify the person is having a breast cancer or not. So that is the task. What is the experience? Patient records, huge volume of patient records with breast cancer and without breast cancer is given to the model. That is called as the experience. So any machine learning algorithms will have to target on these 3 parameters: performance, task, and experience. Again, I'll repeat, performance is the accuracy or efficiency of the model that is built. Task is what is the focus you're going to make out of it. And experience is the data, what you're giving, right? Okay, now the forum is open to you, right? We are playing a chess game, right? In this chess game, we are going to model this chess game using a machine learning algorithms. In this problem, which is a task, yeah, the task is playing a chess game. What is the performance? Performance is how much of game have been won against the opponent. Opponent here is a computer. Okay. Then what is the experience? How number of moves, whatever you make it, from the moves itself, it learns. We can give a predefined data for learning. Apart from that, on the move of the game also, we can have that learning process. What is learning and all will come again in the later part of it. Now, next task, next project is you have to identify. I'm giving the images of the handwritten documents. You have to identify the words from this handwritten documents. Okay, so the task is recognition of handwritten words. What is the performance? How much of words? See, there may be some 15 words. The system can recognize your 12 words. So what is your accuracy? It will be 12 by 15. Okay, into 100%. So what is your E? E is nothing but your experience. It is nothing but a large samples of multiple words are given. Well, even not even multiple words, you can give a characters also. It's given as the input for the system to build. Okay. And same manner, there are two more examples. I need to identify whether my email message is a spam or not. So that is the task. So how many messages you have identified as spam? How many you have identified as not spam? Okay, and for this, what will be the data I'll supply as a database of your emails. Right. So next thing is, so first part I've just covered, giving you the information of what a machine learning is all about, both technically as well as in the daily day-to-day life understanding part of it. Now, why this machine learning is being taught by many people, and nowadays slowly from machine learning, people have moved to deep learning. I'll cover at the end of the sessions where you have to go for deep learning, which places I can apply deep learning also, right? So now, initially to start with, AI has a wider area of its applications in almost all the domains. Now, if you see, even in our college, we make all the departments to learn this machine learning using Python programming. It's been given for all the departments. It has been given for all the departments that they'll be doing a projects or they'll be doing the lab exercise based on the domain specialization. Why? What is the reason? Because nowadays all fields of applications have started using machine learning. So when the students comes out of this college, they should not say that we are not able to implement a machine learning, or even a triple students or automobile students should not say that machine learning is a computer science part. It started on a computer science part, right? We are going to handle the problem through the missions. That's all. Okay. So problem will exist in all the applications. So already we have finished the first applications on healthcare, that is disease diagnosis. We have been talking on women breast cancer. Not only that, you can go for lung cancer, skin cancer, identifying brain tumor, identifying lesions of any parts of the images. Anything can be done. This medical domain, it will be used to identify patterns and also predicts the patient's outcomes. Not only, see, nowadays they are not only concentrating on the diagnosis, they are also going to the next level. Which stage it is? For example, we have identified the person is in the breast. Having a breast cancer means immediately earlier stage or in the intermediate or at the fatal stage. So this also can be diagnosed. This also can be identified. So this is regarding with the health sectors. And when it comes to your finance, we want to identify any persons who had made a false transactions or fraud deductions. All these things can also be identified based on the high financial data. So next thing is marketing. In what ways machine learning can be applied in marketing is for making the customer segmentation. Okay, so we have learned about image segmentation, video segmentation, and all. What is customer segmentation? I need to group the customers and also I need to service the customers. all customers cannot be treated as alike. For example, being a faculty, I have to equally treat all the students, but I want to consider the students' upliftment means I need to group the students and I have to address them as a individual groups, because all in a class of 60, I can have a wide variety of students. Okay, I can address the class as now, need not go for class itself. Right now in your webinar, we have been around some 98 participants are there. It includes a group of faculty, students, and others also, researchers also, maybe, not sure. So in this, I'm now giving a general discussion. Suppose if this webinar continues for one more sessions, one more time, again, I cannot go on the general discussions. I need to group the participants based on the interest or based on the domain in which they originate like that. So in that part also, we can apply machine learning. Here, very well, the suitable algorithm, what we are going to discuss will be your clustering. So why we need to do this? Then only I can address the people and I can have my business to be promoted to the next level. Because we need not give, see, for example, the person who is not having a good income, there is no use in approaching the customers and asking for purchase of credit cards, right? So we need to identify the customers in a position to make the repayment or loan, whatever might be, loan repayment or your credit card, whatever might be. If he's in a position to do that, we have to identify. Then that person's, if we approach, means we can get the business to be promoted. And nowadays we have your driverless cars. So that also works on your machine learning concepts. And sorry, finance is again repeated. Then next one, last one is, it's not only in all this application, even in education it has been used. Okay, not only for doing a project, say all your online platforms, online educational systems, or even for examples to identify which courses is coming up, recommendation systems works on this principle also. It is not only used in only these wide areas, it has been used in natural language processing, image recognition, and already I talked about the recommendation systems. Okay, so the entire most important top 9 problems that has been focused on machine learning. Under this, you have a sub problem. So first problem, identification of spam. So which means you are identifying a fraud. It may be a mail message, it might be a fraud in the finance or in the other sectors also. Okay, see, for example, students are writing up an exam. We have online monitoring systems. We are identifying who is doing up a malpractice or not. So that also will comes under this. Next, we're recommending the products. Now, this weekend we have a plan to go for a movie. Which movie to go? Okay, we need not go and search and find out which is the top movie, what is the rating of each and every movie. Simply, I'm giving a message. I want to go for a movie. My taste or my interest is this. So and so. Get me the movie list. I should get it. So like that, you can go for recommendations. Already I've talked about your customer segmentations. We'll come to image and video recognition. What it is image. I'm just giving an image of a cat. The system should identify it as a cat, not as a dog. Okay. And also videos, I want to identify what are all the objects that is coming over there, how many times the object is repeated, where the object is placed. I want to explain the scene of the scenario. Everything can be done. So all this comes under your image and video recognition, or I can call that field as computer vision even. Next, fraud and transactions, already I said. So we nowadays we are dealing with digital cash, so it should be highly secured. If at all, if there is any issue, means it has to be identified then and there. We cannot depend on people's. Instead of that, we can make the machines to identify that and make the corresponding solutions for it. Okay. So in demand forecasting, this comes over is, now I want to identify which course will be approached in future by many peoples. Okay, which is the demand over there? Demand in the business, demand in marketing, demand in education, anything it can be. And the last one is, we need a virtual personal assistance. Nowadays, started with the joint family, then it becomes a nuclear family. Even still, it becomes a micro family nowadays. So everyone wants to survive on their own. Okay, but any of you need assistance or you need a help. So what are the virtual assistants can be provided? Not for the disabled people, even for the elderly persons, we can think over it. Okay. And sentiment analysis. See, for example, I'm delivering this session today, right? you can do a project on the audio capturing of my sessions and say me, how was the lecture? Was it interesting? What was the mood of the person who has presented this lecture? Was in a happy mood? And the same thing, we can also identify the sentiments of the participants who are listening. Actually, in online class, it is very difficult. Okay, but one thing what we can do is we can make the videos of the participants to be in visible state, or we can have a proper chat messages from the participants. Based on that also we can have the sentiments to be tracked. Okay, just to give a live example I've given, actually the sentiment analysis will work on Twitter, Facebook, Instagram. Okay, and even your WhatsApp message we can take it. So for example, you and me are chatting, okay, for several days. In that case, I want to identify what is the sentiments behind our conversation means we can do it. Okay, and next thing is we need automations in automation is provided in all the places. So customer service automation is given over there. Okay. Can anyone say what do you understand from this picture? Or you can even put the message in your chat. So this is a small image in which we have a set of knife and spoons. The model is there. Okay, when I give a new data as a spoon image, it has to identify as a spoon. And second, okay, there are different types of learnings. Actually, what is learning is, I'm telling you, you have to build a model from the data. So how this model building will be done is, which means, see, for example, I told you, if I show a cat image, the child will say it is a cat. If I show a dog image, the child will say it is a dog. How the child is able to say? Repeatedly, will be showing several cat images. All the cat images from that, the child will remember some features, will register the features in the mind, and based on the features, when you show an unknown image, it will say whether it is a cat or dog. The same mechanism will be followed for the machine also to learn here. We'll give the data, we'll make the systems to learn from this data, and then it will ask the systems to predict when I give a unknown data. So here, this learning part can be done on three manners: supervised, unsupervised, as well as your reinforcement learning. Supervised means we'll give the input, we'll give the output class labels, and we'll ask the system to learn. So once I give the output, always a system can be gone for only these two conditions. So in your previous image, so I'm training the machine only based on knife and spoon. Okay. So if I give any test image, whether it is knife or spoon, it will classify only as either knife or spoon, not beyond that, right? So that is your supervised learning. What else will be your unsupervised learning is, I'll come on to the unsupervised learning later, but anyhow, I'll just tell you, your unsupervised learning now, I won't give the class labels. I'll give only the data. I'll say that you group this data into 2 groups or 3 groups because I don't know what name to give for it, right? Okay, so in a class of 60 students, I can say you group this class into 3 groups, right? So what you will do, we immediately will announce in the class. You yourself form a group of 3, which means what happens? Students will be moving and forming a group. Which students will join together based on the similar characteristics, the students will get joined together. The same scenario only happens over here also. I didn't give any class label and all to learn it. So this data, not this one, like that, it's not given. So automatically it will get joined over there. So under your supervised learning, here there are some different algorithms are given there: linear regression, logistic regression, decision tree, random forest. What is all this? Now, these are all different types of algorithms what you can give under your supervised learning. So this regression, linear and logistic regression, it's a prediction algorithm. Under supervised, we can do two things. Either we can predict or you can classify. Predict now, I'll give the historical data of 10 years or 15 years, right? I'll give a new data and I'll ask you to find out what will be the predicted value. So what it is now, see, in our college, let us take our college itself. I'm giving to the mission the admission data for the past 10 years. Okay, and then I'm putting one question. Next year, tell me in which department the admissions will be moved. All of you can say it is a computer science department, but the trend will not be the same forever, right? Okay, so earlier we had a mechanical civil and all on top on one time of years, and then slowly computers have started. Then one time EC, like that, it is going on and off only, right? So in this case also it will be the same one. So for identifying this predictions, I can either apply linear regression algorithm or I can apply logistic regression algorithm, right? Then what is this decision tree random forest? This is for classification algorithms. So decision tree, from the word itself I can have here, we have a tree. Now this tree, you'll have the branch, will have several.
Ma'am, screen sharing is not visible on my smartphone.
Kalaivani ma'am, the presentation has got closed, ma'am.
Hello.
So can you see my screen?
Yes, sir. Yes, ma'am. Yes, ma'am.
Yes, ma'am. Yes.
Oh, okay. So that is a random forest means it is not based on only single decision. We'll have multiple decision trees to be conducted. This will reduce overfitting and improves prediction accuracy. What does overfitting means? See, there is two types of issues, or we'll come to the issues that time I'll tell you. We have one issue that is called as overfitting or underfitting. This is what for now. I told I have 2 or 3 class labels. For all the class labels, the data should be equivalently distributed. But in many cases, what we'll have now, either we'll have a data, more data to be available for a particular classes, that is overfitting, or I'll be having a less number of data for a particular set of classes, that is called as your underfitting. Okay, so that has to be taken care. That will come to a later part of it. So these are the algorithms you have, and apart from that, one second. So apart from that, you also have your neural network algorithms. This algorithm will work similar to the function of your neural system in our body. It consists of a lot of nodes. Each nodes will be interconnected. This neural network algorithm serves as a base for nowadays deep learning networks, right? Then unsupervised, already I told you, here I don't have a class label, no supervision. That is only called as your unsupervised. Why no supervision? Because I don't have a class label. So this record belongs to this class. Like that, we don't have like that. Okay. So I'll give a set of records and throw a set of records. That records has to be grouped together. After grouping it, we can find out, we can give a label for that. Okay. After grouping all the students, I can say the students, these are the students who have been very good in their academics. These are the students who are good in their other activities. Like that, I can name it, right? Why? Because now on an open classroom, I'm saying form 3 groups. Very well, the students of the similar characteristics will form a group, right? So from the group, any one person's, if you see what the characteristics, the same characteristics will be exhibited by the other people with a less variant, but not at a larger difference, right? So this is what is relating to it. We have discussed one problem called customer segmentation, right? That will come under this category. Next one is reinforcement learning. So this is what learning that has been adopted in your video games, your chess game, everything, right? Almost we cannot determine and make the mission to learn, right? What we'll do, will train the mission or train the system in such a way that we'll give a set of moves, and also will make the moves to learn from the system when it is online. Okay, one example I can say over here is, say I want to identify the traffic scenario, that too mainly at the time from 6 to 8 in remote in places. What we can generate to will be busy, not like that. If you take even Ranganathan Street, if you just see at the end of the month, you cannot feel to be highly crowded over there. Okay, but the same scenario I cannot say if it is in a festival season, right? So what happens here is, we are getting a streaming data from the scenario, from the place, and then we are coming out with the some decision making or some results. Means that is what is called as your reinforcement learning. All situations cannot be given well advanced. Okay, I cannot give all type of data which is possible for a patient to get a cancer or not. All symptoms we can take into consideration, but all symptoms is not possible to give it for all type of patients, right? So this reinforcement learning will be very good, but we find very few people are working on that. They are thinking that only for game problem it will be there. It's not like that. Where I have some insufficiency of data, and when I want to apply machine learning model and we want to learn from the data itself. Okay, so as and when a new data comes, that new data is not there, it has not been available, this new data can be added as a training data, right? Then what are the various issues in developing a machine learning model is, first thing as I told you is inadequacy in data. The data should be having a huge volume of data. See, if you don't have a huge volume of data, it will not be able to learn the data under different circumstances. That huge volume of data not only speak about the number of columns, not only speak about the number of rows, all scenarios of the data has to be taken care of it. That is the main thing. Many machine learning problems, what the people will say is, we have a poor quality of data. And in some cases nowadays, even if you go for deep learning models, what do they have now? For deep learning models, by default itself, you should have a large volume of data. If you don't have now, what people will say, that they'll go for data augmentation. What is data augmentation is? Nothing but you're manipulating or you're creating a new data. But what happens over here is, when you creating the data pattern, what I cannot come up with a new pattern of data for that particular case. So that has to be taken care of it. And I told you overfitting, underfitting. There are some three class tables. A particular class A alone, there are some instances. For class, I have only 200 instances, which means what? I have totally 1400 records. In that, 1000 records are there for class A and 200 records for class B, and remaining 200 records for class C. What will happen in this scenario? If I give a new data set, the chance of classifying the data set as class A will be more. Why? Because for class A only you had a lot of experience data. Okay, so that is the problem you'll have if you. This is a case of overfitting. Just the opposite. Now class B and class C is what? It is an underfitting case. Okay, so we should not have a data set like that. We should have an equally distributed. So whenever we start with a machine learning project, don't simply download the data from the Kaggle. Look on the data, work on the data. Okay, check the data, and then you start the process. That is the most important thing. I'll come to the process, what and all you have to do it over here. Right, now this is a small example which will show you how it will teach a mission to identify or to build a model. Right, so look at that images. Here I have a set of cars and bikes, right? Wheel, height, weight, color. What is all this for? All this for is a features. Okay, so this feature are represented as F1, F2, F3, F4. Okay, so this entire feature is called as a feature set. So the feature set, here I have 4 features: wheel, height, weight, and car. Right. So here in this screen, we have given the values for it. Okay, when you look at the wheel parameters, I can have 2 types of wheels. Don't look at the image, right? Okay, so when I have the wheel parameters, I have wheel of 4, or I have a wheel of 2. Same manner, height here I have 6 or 5.5, 5, 3, 3.5, like that's right. And weight here I have given here as 500, 600, something, all the values are there. And color is the color of the vehicle. So first image, red color, blue color, yellow, like that it has been given there. Okay. So now for every object, you have given a value, and this value constitutes your entire feature vector. So this 1, 4, 6, 500 red, that is first feature vector. Okay. So your entire data set is a set of feature vectors what you have. So your data will be taken like this. So you mean to say, can't I give my image directly here? You can give an image here. From the image, this features has to be extracted in order to build a machine learning models. This is where your deep learning differs. Let me come to that part at the last, right? Now, in the beginning itself, I told you when I want to make the missions to build the model and all, you need to know a little bit of statistics, right? Now here, this is PR is nothing but probability. Probability of car to have 4 vehicles, how many things are there? So car actually, how many rows of data is here? There? Actually, here there are some 6 data, right? In the 6 data, 3 data is car and 3 data is all the 3 data. If you look into it, all is having a wheel of 4. Okay, all the bike data you look into it, all the wheels of bike is 2. So when you take the probability of car of 4 wheels, it is 100%. And if you take the probability of car of 2, it is 0%. Sorry, car of 2 is 0%, whereas bike of 2 is 100%. Now, you just see here a new image is given there, where they have given the only the one value wheel. Wheel is given 2. Now tell me whether it is a car or bike. So all wheel is 2, the probability of wheel 2 with 100% probability is to be to a bike. So I'll get the answer here is bike. See, this is a simple data set. This may not work good. It may work good with this type of data sets. Now you just look at this data sets, right? Same thing only. We have added some more rows of data. Okay, earlier we had 6. Now here we have 7 here. Can you find out what is the change between the previous data and this data? Here we have car of 3 records. We have bike of 3 records of wheel 2 and a bike of 1 record with wheel 4. So the probability changes. Why? Any answer?
2 wheels of car.
Probability of car is we have 3 records, but 3 records the wheel the number of wheel is 4 here, and bike we have 1 record, that also the number of wheel is 4. So now if I take probability of car with wheel 4, out of 4 records we have 3 records 4 wheels and 1 record 4 wheels, but the object is bike here. So earlier record, I got the probability of car with 4 wheels as 100%. But as for this data sets, the probability of car with 4 will be 75%. And if you take for bike, 1 record is there. So that is getting here as 25%, right? So based on this data sets, actually don't go in depth of it. What actually it means is, what is the learning thing this machine will do in your previous case as well as for this case. Depending upon the data what you provide, the learning will happen. That is what I want to conclude it, right? But can I decide either it is a car or bike based on only one feature? Na? That is not correct. Okay, so the selected feature is not sufficient. That is what here it says. So what happens here is they are including one more feature called height. Okay, height earlier when I just started, I've given some values over there. Instead of that values, we are giving it some abbreviated. So when it is beyond this threshold value, I'll label that height as high, or if it is below, I'll give it as low. So based on that, again, we have taken probability of car with 4 wheels and height as height. Probability of car with 4 wheels and height as low. Like that, what as a percentage is arrived. So based on this probability, it will just come up with the rules. There by any new instance if you give, it will just tell you what class it is, right? Okay, so this is one examples where the finally it is arrived by constructing a decision tree, right? So here the wheel is taken as the root node. Okay, there may be a question, why wheel is taken, why not height? How we'll decide which node to take as a root node? Again, we'll apply a statistical measure. Here we have different types of statistical measures to find out which feature to act as a root node: entropy, Gini index, information gain, all these are statistical measures which will be used to decide which feature can act as a root node, right? So in this case, wheel has been taken. So again, wheel, there may be two branches. Height is H, height is, one factor is B. So wheel is for the yes. Wheel is not for the no. So one path there, one path there. Again, what will be the next feature? I'll have it height. Height I have the height here I've taken H. H means higher height. Higher height is there by yes. No means lower height. So when we look at the images, final classification, if you see, if there is a wheel, but the height is lower, there is wheel of 4 and the height is lower, means there is a chance of the vehicle to be a bike. Right. The wheel is 4 and the height is higher, means the vehicle is to be of car. Again, that side you just come up. The wheel is not 4. Height is higher, means there is a chance of being a car. Okay, the wheel is not 4 and the height is lower, means there is a chance of being a bike. So for classifying your car and bike on two features, they have come up with this algorithm for the given data set. This is how the learning happens, and then it will come up with the rules. Was it clear? So this is a small example, what I showed as a demo, not a demo actually, as illustrations for you to understand how the machine learns. Simply we are saying the machine learns by itself when we give the data is based upon your features, and also we are giving the class label, now how it learns. It will do some calculations, it will apply algorithms. How that algorithm works, it will be based on your statistical measurements, and then it will does it, right? Next thing is, okay, now I want to apply this machine learning algorithms using some softwares, and I want to do my coding part and want to complete the project. In that cases, earlier, even when I was doing my research, Python was not there at that time. I have done my machine learning code only with the MATLAB. Okay, and there are also many open source softwares are available where you can do your machine learning code. Even in Java, there is one code called Vika tool is there. Through that Vika tool also, I can have my machine learning code to be implemented. Now, latest nowadays, people are working with Python. The reason here is you have a lot of libraries available for that. So simply if I import the libraries and I can do that work. See, for example, if I do in my MATLAB, I too have that functions available for me to import the algorithms and all. But anyhow, that facility is not wide as we compare with the Python nowadays, what we are having. I had a practice of writing a hard code. Now we have been working on smart coding, right? So here, what are the libraries I can have here is NumPy. So this NumPy libraries will be useful for making your numerical calculations in order to handle your arrays and matrices of larger size. So the previous data set I showed here, no? So the feature vector is nothing but your matrices. Okay, it is not with what data I showed you. I showed a data of 7 rows or 7 rows with 3 features and all like that. But actual scenario, we may have an n number of features and m number of rows will be there. So that can be handled using your NumPy. And you have after handling the data, I want to have the analysis visualization tags and all. We can do very well with your pandas. And what is the tool or library which supports for implementing your machine learning project is scikit-learn. Okay, so this will be the most important part for your machine learning part. This supports classification, regression, clustering, and dimensionality reduction. So all these keywords I told you. What is this dimensionality reduction is? Say for example, I'm taking a data set. Let it be real time or it may be a benchmark data set, right? In that data sets, I have m rows and n columns. I'm saying it, right? So that m, for example, let me take that is 10,000 rows. And number of columns, let me take it as 100 features. So 10,000 into 100 will have around some 10 lakhs data to be available. Do I need all this 10 lakhs data to be taken into consideration for my model? Really it is useful, really it is important means we can take into account. See, some out of this 10 lakhs row instances, some row may have some missing values. Some may not have given the values, what that is given is not correct also. So if I come across like that, that rows either can be removed off or it may be filled up with some values, right? So when I fill up with values and retain the same rows, there is not dimensionality reduction. If you either eliminate the rows or you eliminate the columns, instead of taking 100 features, I'm applying feature selection algorithms. I'm getting 670 features. Okay, 60 features I'm taking, the 40 features you're dropping out, which means 40 features into 1000 records. 40,000 records get reduced. So that is called as your dimensionality reduction. Is it necessary? Yes, it is necessary. All features in your, see, if you collect the data means you may find it out all the features are important. Right. But if you take the benchmark data sets or data from Kaggle's or GitHub, whatever might be the source, that is what we are using it. In that cases, the data sets may not be so good enough. So some fields is not relevant also. It is not going to play a major part in model building. So that can be dropped out. And the TensorFlow is mainly used for your deep learning concepts as machine learning and deep learning. Machine learning you can do with Scikit itself. You need not go for TensorFlow and all. But if you are working with the deep learning models, means you have to install your TensorFlow. And I want the API, front-end application interface, need to be built on the TensorFlow, means you have to use your Keras. All this can be easily downloaded and added with your Python. Apart from that, no, I'm finding it very difficult. I'm not having a GPU processor or a good processor to make my systems to work means no issue. You work on your Google Colab and make the things to be done, right? And apart from that, there are a lot of IDs available for making your works to be highly interactive. So one thing is Jupyter Notebook, Anaconda, Spider, Matplotlib. This is Matplotlib is for making a visualization. I want my visualization to be included means you can have it there. And Seaborn, again, it's a data visualization library and it will provide a high interface. See, whatever you do, finally what you're going to have it. We want to come up with a good decision-making system. So that decision-making, what type of interactive visual presentation I can give it over there means that can be done with your Seaborn, then compared with your Matplotlib will give you the basic visualizations. When you use your Seaborn library means it will give a interactive visualizations. That will be useful for the management people in order to go for the decisions. Okay. And whenever you are doing your machine learning models, first thing is pre-processing, right? So what is your pre-processing models? As I told you earlier, pre-processing, they may be just handle your data with care. Simply don't take the data from the Kaggle or GitHub and then start working on it. That may not be so correct. So first you look at the data and see whether is there any missing data. Do I want to encode categorical variables? Now, just know what we did for height. Height, we had a numerical value. But with the numerical value, it is very easy for me. It becomes very difficult for me to identify or categorize what the feature is all about. So on this range to this range, I've categorized the height to be low. On this range to this range, second range, I'm giving that the height to be as a high. So like that, we can do some categorizations and scaling. Say, for example, if I take scientific values and all, I'll be having a large number of digits after the decimal points. So, but such a lengthy digits, see, not one. It's not going to make a much difference with not two. So in that cases and all that scaling can be applied. You can make it same manner. For example, income you take income and people are having a drawing income on 6 digits. People are drawing income on 5 digits. If you want to scale that to one particular CAD, so people income from 0 to 20,000. I'll put it in scale 1. 20 starts from 20,001 to 50,000 or 40,000 scale 2. Like that scaling can be done. Then feature transformation is what I told you is, so certain features you want to include it, you want to exclude it, we can have that. And for example, I don't want that. For example, I have a transactions. Okay, so during my transaction, business transaction, they may give a mobile number. Mobile number is not going to play a vital role for my model building. In that case, the mobile number can be dropped out. So whatever the data you have collected or you got it from the repository, just look into the data, do careful pre-processing part, and then only you have to go for the next step. So when we are doing your machine learning model building, the first part is pre-processing. Next thing is feature selection. Now I've got some certain number of features. Whichever features you want to do, include it, you include it, otherwise you exclude it. It's not very easy to decide it. As I told you, we have a Vika tool. In that Vika tool, there are beautiful algorithms are available. So with the usage of that algorithms, statistically we can decide. See, I cannot drop a variable, drop an attribute as such. On what justifications you are dropping that attribute, or how to identify whether the feature is relevant feature for me or not. It is very tedious for you to do manually or through computation also. So we have an inbuilt algorithms available for that. Ranking algorithms are there. Searching algorithms are available in order to identify which feature is needed or not. Like that, that can be used. So first thing is pre-processing. Next, first before pre-processing, data collection. So data collection, pre-processing, feature selection. Then only the model building is to be done. So when we go for model building, we have a data. As I told you, I have 10 lakhs of data now. The 10 lakhs of data should not be given for training. Okay. So 70-30 rule is followed. So 70,000 data I'll take for training and 30,000 data will be taken for testing. So 70,000 data training now with the class table. We'll assume that we are working on classifier models, right? So that data, what will happen? It will take and it will build the model on any algorithm based, right? Now the 30% test model data is there, for that model. Class labels will be taken off. This 30,000 test record will be given to the model and the model will predict the class labels. How the model evaluation will be done there, this 30,000 records go, already you have a class label, but when you test all the model, you are giving the data without the class label. It will predict the class label and give it to you. The predicted class label and actual class label will make a comparison, and with that, the model accuracy is evaluated. Based on the accuracy of the model, you can either fine tune it or it is the performance is good now, you can proceed for your deployment. Before deployment, you can also test again with different types of data samples, right? And how I do model evaluation? Simply, I cannot say only, okay, I got the performance good. That alone, it's not enough. We can do the model evaluation with various techniques: cross validation, confusion matrix, receivers curve it is, and then precision recall curve. So all applications or packages, whatever you are coming up with the machine learning, they will have the results to be given for all this. You can have a cross validation tenfold. Tenfold cross validation means what? The entire data set is divided into 10 partitions. 9 partitions will go for training and 1 partition is for testing. It is similar to what I told for 70-30 rule. And confusion matrix is what is now the test set will get you the confusion matrix. See, I told you in the previous case, 30,000 records are taken for test instances. 30,000 records, like each class label 10,000, I'm having it. Out of 10,000, how many records have been correctly classified? How many have been wrongly classified? Confusion matrix, right? And this is receiver curve means it's a graph representation of showing the true positive rates against the false positive rate at various threshold settings. Okay, so same manner precision recall curve is there. Okay, so precision recall, it's metrics for measuring the performance, not your accuracy. So accuracy F score can be calculated based on this. All these are metrics. If it seems to be Greek and Latin, don't worry. When you start doing your project, you'll be exploring all this, right? And whenever I want to include your scikit library, after installing your Python, you have to include your Anaconda and also include NumPy, SciPy, and scikit-learn for installing it, right? So here I have some 2-3 algorithms explanation over here. So let me take first one as your SPM. SPM means, any idea? SPM. SPM is nothing but your support technology, right? It is one of the algorithms, right? So now what it will do? You can post your answer also in the chat. Okay, what it will do here is, okay, so support vector mission. See, I have a set of data points, right? Now, if you look at the graph here, I have a set of data points of blue color and red color, right? Now I want to separate this data points. So I need to identify a line of separations that separates my blue points as well as the red point. Okay, so that is what your SVM mission is going to do. Here, if you see that line, there is a middle line that is your SVM vector. On that middle line also, you can see a red dot as well as a blue dot. But what happens here is this red dot and blue dot will be, it's lying on the plane. So out of some 10 dots, 4 dots are classified as red properly and 4 dots are classified as blue properly. And the dash line denotes your hyperplane. Okay, before getting that SVM vector line directly, I have this hyperplane to be done with. So now what happens is, once I got this training model, if I give a new data, the data will be acting on this hyperline and it will be either above the hyperline or it will be below the hyperline. So this is your SVM model. So this is a small code. So here I told you we have to import numpy. What for me? Because you are handling a data of matrix size. And then import your skyline. And sklearn, what you are doing is we are importing your SVM. See, this is the feasibility of your Python. So SVM classifier is already built up there. We are just including that SVM classifier over here. We have taken some training data sets. Okay, we are loading that and making it as a main frame data here. Take the data and load it into the frame, and then you are moving it to the variable data here. Now in this data, we are taking up for training as well as for your testing. Labels is in the last column, and all other remaining fields we are taking out. Like that, you just divide the data for test data also, and then this is your main part. Apply your SVM, and it's a linear SVM, which means we have a single SVM classifier, and also we can have multiple SVM classifier. Your linear classifier is what is a linear line, what we got it. So that we are doing it, and we'll give the test data, and that also will be predicted, and it will give the prediction. What is this error is, how my model is all about. Once again. Okay, how my model is all about, what is the efficiency of my model, that will be listed out here. And error is nothing but the error rate divided by the length of your test labels. Okay, so we need not go in detail of all this code. Very important thing is, this shows how you can implement your SVM overview, right? Same manner here, I have other code for decision tree as well as random forest. What is decision tree? Any answer? So it's a classifier algorithms where we will we'll identify one of the feature as the root node, and from there the classification splitting starts, and your leaf node will be your class labels. So root node to the leaf node, I may have varietal paths. All that varietal paths is going to be my if-then rules. Okay, so the learning model, what output it will give, it's going to generate so many if-then rules. So if I give a new test data, this test data will work on this decision model and it will get me the results, right? Then what is random forest is, instead of having a single tree, I can have a multiple trees also to be available, a good branching, and also I told you your overfitting data can be handled very well when we go for your random forest. That is, instead of handling the overfitting data, with the overfitting data, I want to work on it now. Very well, you can use your random forest algorithms and you can get your results, right? And here also, similar to that, we have a program given, a sample program is given for how to work on your decision tree and random forest. Is it clear? So one SVM classifier I've given you, and then just an overview. We have not gone in depth of it, right? Then the next algorithms what we can discuss over here is unsupervised learning, like clustering. I told you already. I told you clustering is nothing but the grouping the objects of similarity. Okay, so how I find out the object is similar? See, when you and me are talking for some time, we know what is the similar characteristics, what is the likes and dislikes of you, and then we can find whether our conversation will continue, how it will continue. It depends upon your likes and my likes matches, right? So when we are talking about the values, your data, you are telling the machine to identify the similarities. Now, how it will identify the similarity? It's nothing but each data points distance will be measured. Okay, so now the data points are cluttered on a vector space. In that data points, which are the data points are close together, it will get attracted. Take your magnets. Okay, bring the iron pieces. The iron pieces which are close to the magnets get attracted. Same manner, the smaller distance are just data points are grouped together, and the data points which are farther from it will be grouped in the text cluster. Okay, so to initially start with, for example, I'm saying that I want a two cluster, which means two center points are given. So the center point is the two magnets that will be placed in the vector space. So with the two center points value, which are the data points that are closer, will get cluttered into it. Right. So, and one more thing was when we are doing k-means clustering, is a very famous clustering algorithm, or should have been known of. Right. In this k-means clustering, what will happen here is we have to tell what is the number of groups you have to form, right? And also here the random centroid will be taken into existence. But we had a lot of k-means algorithm have come up now in order to get the number of clusters itself to be automatically generated, and also to assign, not assigning random centroid. Why random centroid happens means every time if you run the clustering algorithm, you'll get different results. So today I'll be in this group. Tomorrow I may be in another group. Why? What is the reason? Because based on the random centroid value. Okay. So this is the major issue of clustering algorithm. And many statistical measures have come to overcome that. And we can tune this k-means clustering algorithm and we can get the better results also. But here you see here, the number of cluster is given here 2. And what is the centroid here is your initial centroid, right? And if you look at this things, you see here, this is the first graph shows how the data points are cluttered together. And that has been showed by the difference of your colors, right? And again, one more thing is said, this is by machine learning, and this is actually the bottom figure is the actual clusters earlier we had. After applying your k-means clustering, you are getting the top figure, right? So this type of visualization also we can have it. That is what we told you to include your matplotlib also for this, right? So let me have a recap of what I've told you. So initially we have started with what the machine learning is all about. What are the definitions set by the researchers, right? And next, slowly we went for the various applications. What is the top 9 problems we have? That is, any machine learning problem or projects can be grouped under the 9 category. It's a general problem what we have discussed it. Then we are keep on saying that we make the machine learn, make the machines to learn. How the machines can learn, we have taken a small data sets and showed you the illustrations. And we want to work machine learning projects using Python language, means what are the requirements that is needed for it. And before that, what is the machine learning process actually all about? So there we have discussed data collection, pre-processing, feature selection, model building, model evaluation, model deployment. All the stages we have to go. Once we finish up all the stages, only the entire project gets completed. And after that, in Python library, what are the things that is available? Python tools, what are the things you can add it up for? What are the IDs that is supported in order to do this? See, if I'm able to do with the Jupyter notebook itself, you can do that. You need not go for your Anaconda and all. But if I'm working on with a real data sets, means it will be useful, right? And we have discussed the algorithms of just a snap code of your SVM classifier, decision tree, random forest, then your k-means clustering, right? Last point I want to share here is, here I've told you all the things what we have discussed right now is machine learning. But we may have a thought, now people are working on deep learning. Okay, is it necessary to take up my project or my research in deep learning? It depends upon your applications. Right, and it depends upon the data what you're doing it. As researchers are working on deep learning model, I have to go for deep learning model and not at all. It is not like that. Nowadays, days are gone to have a hard coding. Now they are working on smart coding. Now AI has moved towards generative AI. Okay, so there is no hard coding phenomena and all. If you give a keyword, working on the chat GPT, I know very well. Once you give a keyword that is able to get everything for us. Right. So since that added features have come up, we need not sit and just take a code and do it. And if it is needed, only we can go for your deep learning. Since all are doing deep learning, I'll get a better results. Like that, many people are speaking out, but that is not actually correct. When you want to do your research in your deep learning, the first thing is you need to have a large volume of data. So that large volume of data, if you are not having itself, the model cannot work. See, with the limited data, you can have work on your machine learning algorithms and you can get a better accuracy. But the same data, if you put on a deep learning models, you'll say that the accuracy is not so good. Reason is deep learning has come up only in order to handle large volume data. People are playing with a small volume and they are doing some data augmentation process, whether for images or for the data, and trying to get out the results means you cannot meet the objective. So the side of the applications, uh, as for the end user is considered, it is not that you are going to get what technology you have applied, what algorithms you have used, that and all. It's not at all the point of the end users. What is the point of the end user? What the end user is expecting is, this is the requirements I gave, whether your mission is able to satisfy my requirements or not. Background of what technically you're doing it is unrelevant or unaware of them. If I go and teach them deep learning or if I go and teach them machine learning, how it works and all, they are not interested and they are not required, right? So make the thing simple as per your research focus and explore more. And if you have any questions, you can ask me. Thank you for your patience listening. Thank you, Ananda.
Participants, if you have any query, you can clarify it with unmuting yourself. Participants, do you have any query to ask?
Yes.
No question, not clear, huh?
Yes, you can. Someone ask us question now.
Or you post the question in chat box also. I think I've taken the
evening,
time,
madam.
the lead. Yeah,
Madam, excellent presentation, madam.
thank you, sir.
Very well explained. Within the small time, you covered most of the machine learning models and different tools and libraries. It is excellent, madam.
Okay, sir. Thank you, sir.
Madam, I need some more explanation regarding AN and ma'am. Please give some
So
more
I'm
details regarding AN and ma'am. Artificial method.
I've given my mail IDs. So anyone want to have any questions, any discussions in future also, you can approach me. I produce my research scholars in the area of machine learning only. Right now, my student is also working on deep learning, and I'm guiding my students' projects also in the deep learning. Now only right now I'm exploring. Right, so I've been working on machine learning. So any help, any guidance also, you can approach me. Let the session need not be end by today evening alone. I'm ready to help you at any time. You can drop me any queries also in your mail through my mail ID, what I've been shared in the first line. Thank you for your feedbacks.
Any other queries? Okay, thank you, ma'am, for your wonderful session.
Thank you, sir.
Now I call upon Mr. Zahir Zubai to deliver the vote of thanks.
Before we conclude, I would like to extend a heartfelt vote of thanks to Dr. A. Kalaivani for her invaluable insight and expertise shared with us today. Where gratitude has been truly enlightening. I would also like to express our gratitude to a resources person, convener, director, assistant director, clump head of the department, faculty members, students, and all the participants for this active participation and engagement throughout of the webinar. Our contribution have been enriched and learning experience immensely, but not the least. The special thank of technical support team ensuring a smooth and seamless execution of this webinar. With that, we conclude today's section. Thank you all once again for the active involvement. We're looking forward to the meeting future in this. Thank you.
Thank you,
Thank
Zubai.
you, Sabarishar and the organizers and the college management for giving me this opportunity. Please stay in touch with me. Any help, I am ready to help you all. Okay, thank
Yeah,
you.
ma'am,
Okay,
sure.
okay. Yeah, thank you.
Thank you, ma'am. Thank you for the wonderful seminar.
Sir, can I disconnect?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Yes,
Thank
ma'am.
you,
You can.
sir.
You
Yes,
can.
ma'am.
You can.
Participants, feedback link has been posted in the chat box. Kindly fill it so that you can get your e-certificate within 7 working days.
Hello, sir. If possible, please provide PPT, sir.
Sure, sir. Share it the WhatsApp group, sir.
And also, Madam mail ID also, please.
Definitely, sir. I'll share it.
Mm.
Participant, kindly fill the feedback link. It is available in the chat box. Go, sir.
சொல்லுங்க சார்.
ஒரு 2 minutes க்ளோஸ் பண்ணிக்கலாம். feedback link மட்டும் எடுத்துக்கிட்டோம்.
Okay, okay. No problem. No problem.
Okay, sir.
சார் யூடியூப்லயும் லிங்க் ஷேர் பண்ணும்.
பண்றாங்க சார். யூடியூப் லிங்க் ஷேர் பண்றாங்க.
ஓகே.
உஷா மேம் ஷேரிங் சார். கோ சார். சொல்லுங்க மேம்.
Sir. Sir.
Participants, have you filled the feedback link? Shall we close the session?
Participants will give 2 more minutes. So kindly fill your feedback form.
No, sir. No, sir. No, sir.
சொல்லுங்க சார், சொல்லுங்க.
க்ளோஸ் பண்ணிக்கலாம். இதுல வாட்ஸ்அப் குரூப்ல போட்டாச்சு லிங்க்.
ஓகே, க்ளோஸ் பண்ணிட்டுமா?
ஓகே சார்.
ஓகே.
தேங்க்யூ சார்.
தேங்க்யூ.